So this is that area I was just looking at, showing you. Here in 2000, it's all forest. 2002, you can see there's starting to be a little bit of deforestation. 2004, there's been more. And by 2006, there's this big road network here. And we can run these analyses because we have access to lots and lots of satellite data. If you think about Google Earth, we have some snapshots over time, so you can use that historical slider to go back to some times. But we only have a few shots, and they're very high quality, very high definition shots, but they're only a few. And if you want to do a sort of long scale analysis, you need access to all the data. So before I go on, let me find out who here uses satellite data in their work. Okay, a few people. All right, so I'm going to go over satellite data processing, but Earth Engine also works on not just satellite stuff, but also vector information. But I'm going to focus on the satellite data for this talk. So if you do satellite processing, this is kind of how it's traditionally done. So there's a satellite, it's going around the Earth. Different satellites go around more frequently than others. This is MODIS satellite. This one goes around once a day, so you get daily coverage, but the resolution is a little bit low. There are other satellites that go around more slowly, and they take better images, but you don't get the same frequency. So this satellite's going around. It downloads data to a data collection station, and then you can get data from there. So if you want to analyze some data, you grab the data, you download it from the internet, and then you save it on your hard drive. And depending on how much data you want to analyze, you might need a lot of hard drives to store all the satellite data because they're big files. And then once you download the data, then you need to have some computers to analyze the data. So you have like maybe one computer, or if you're lucky, you have a little cluster of computers, but you need some kind of hardware. And then running on the hardware, you need some algorithms. You need algorithms to figure out where deforestation is happening, for instance, or you need algorithms to clean clouds out of cloudy data. Right? And these algorithms, you have to get them from someplace, and it takes, you need to talk to the right people to get them, and often they are in funny languages that may not work with your system. So you have to get them from somewhere, and you have to install them on your computers so that they can run on the data you downloaded from the collection station. So then once you've detected deforestation, or done whatever algorithm you want to run, sometimes you want to validate it. So you go out into the field, you validate it, and you sometimes you'll fill out a form, and bring the form back to your office and enter it into a database using a lot of paper. And then after you've done the validation, and you're ready to report it, you find some way of getting the word out. So this is the traditional kind of path that you go through to analyze satellite data, from collecting the data from the satellite down to publishing a report. So what we're doing instead is we're moving a lot of this stuff to the Google Cloud. So our idea is that you can go to a website and do a lot of this work, or you can use your phone to do some of the validation. And everything happens in the Google Cloud. So actually, when I talk about the cloud, the Google Cloud, what I mean by that is a bunch of Google computers that are somewhere, and you don't know where they are, and you don't know how many computers you're using, right? So if you use Gmail or Yahoo Mail or Hotmail or any of those things, you're using the cloud, right? You go to your email account, you're downloading the data from somewhere, but you don't know where those data are, and you don't care where they are. They're just somewhere, and you're better off not knowing. So that's what the cloud is, right? So all this cloud talk, that's basically the idea. So our idea is to move a lot of the stuff into the cloud. So we have a big data archive. We've been downloading tons of satellite data, and we have other data sets, which means that you don't have to download it yourself. It's kind of sitting there in the cloud. And you don't need to store it because the data is sitting there in the cloud. Google has lots of computers. There are lots of computers that run search. There are lots of computers that run Gmail. We have many, many computers, and they all have some, time. So we can use those computers to do analyses, which means that you don't need a big cluster of your own. You still need algorithms to analyze the data, but our idea is that a lot of the algorithms can run on our computers in our cluster. So you can use those algorithms in the cloud. You don't have to get them yourself and stick them on your hardware because we have them. Or you can code your own and run them in our system. So you don't have to do that. Data collection, later today, I'm just going to talk about Open Data Kit. So the idea there is you don't need lots of forms. You'll be able to collect data on the phone and use that to validate. And then you just heard about Maps Engine and Fusion Tables. So the idea is that that will be publishing the data through the cloud. So our idea is that from the time you want to sit and do an analysis to the time you want to report the results, you'll be able to do it all without shifting a lot of data around. You'll be able to do it all in the cloud. So that's where we're going. That's our approach. You need this. So this is the Earth Engine part. So the Earth Engine part is the data analysis part. There are a couple of different parts to it. There's on the bottom, there's a bunch of data that we've been downloading, and I'll go into more details about that. And then we have these computers, lots of computers to do the analyses. And then on top of the computers, we have an API, an Applications Programming Interface, which lets you develop your own algorithms or use other people's algorithms to analyze the data. And this also lets you build websites that run the algorithms. So this is kind of in a nutshell what Earth Engine does. It's data, algorithms, an API for running algorithms, and websites built on top of that. So here's some information about the data catalog. We're getting daily data in, so we're getting Landsat data as it comes in. So Landsat is one public data source of planetary information. We're also getting MODIS data in, that's the one that goes around every day. We also have a historical archive. We have as much data as is available through the USGS, thanks to them and NASA for collecting the data and making it available. It's all sitting on spinning disks, so you don't have to sort of you don't have to wait for it to be processed. We already have it. You can just grab it. It's 40 years of data, which is it's kind of mind-boggling. You can go back to the 70s and look to see what the land looked like in the 70s and compare it to now. And it's a lot of data. So on top of the data, we also do some processing on it. And we like to say that between the data and the processing we do, it's about an exabyte, virtual exabytes of data. And an exabyte is a lot. It's equivalent to all the printed material that humans have ever made. It's like 25,000 hours of HDTV. It's a lot of data. So that's all kind of available in the system. We have elevation data and atmospheric data. And you can also upload your own data, and I'll talk a little bit about that later. An important thing to know about this data is that we store it all in its original form. So satellite data is different than the data that you see in Google Earth. In Google Earth, you see sort of red, green, blue imagery, and it looks really good. But the data that originally came from the satellite has a lot more information. So now I'm going to do a little bit of discussion about why it's nice to have that information. This is the electromagnetic spectrum. Right? So we have down here radio waves, up here gamma rays. In the middle is the visible spectrum. So these are our friends red, green, and blue. But there are also other sources of information that the satellites collect. So they have infrared information. And a lot of data that's useful for discerning land cover types is in this near infrared. So the satellites collect all that other information. And what's nice is, from that other information, you can see things that you wouldn't ordinarily be able to see. So, for instance, here is a shot around Yosemite taken in November. This is from a satellite, and it's really kind of hard to see what's going on. This is the red, green, blue image that you would see in like Google Earth or something like that. But let's say that you were interested in looking at plants. You want to know where are the plants here? Where's the photosynthetic activity? Well, you can't really see it in here. But if you sort of do a combination of these two bands, so the red band and one of the infrared bands, the vegetation pops out. So looking at that, you can see here the green areas are where there's more vegetation. So from this picture, this is the same image, right? Here you don't know where the plants are, but here you can see where the photosynthetic activity pops out. Now let's say you're interested in snow and ice. You want to know where the snow and ice are. Well, there's a different set of bands, the green band and another infrared band, which a combination of those helps those pop out. So now you can see where the snow and ice really pop out. What can you do with this information? So one thing that's interesting about satellite information is it doesn't look as good as the stuff you see in Google Earth. The raw data isn't what you see. So here's an image from Landsat. It's a little bit fuzzy. This is the area of the Survey territory that we've seen earlier today. You can see there's some farms in here. This is good. This is a really good shot. If you get a shot like this, you're really happy. Because more typically, you get something that looks like this. Right? So this is Landsat 7. The Landsat 7 is a lovely satellite. It gives us all kinds of great data. But around 2003, it had a hardware failure. So all the images from Landsat 7 have this missing data. Right? So that's not so great. And you can also see it's a little bit cloudy. And clouds are the bane of a remote sensing person, right? And actually, you also get images like this, where this is the same spot. So it's got the banding and clouds, and it's kind of a mess. And so the question is, what do you do with data like this? Like, how do you actually analyze it? And that's what the analysis part of Earth Engine is all about. It lets you deal with this noisy satellite data and come up with really nice products that you can use for your conservation work later. So here are the kinds of things you can do with the platform. One thing is, a basic thing, is you can get an image out of our archive. And the nice thing about this is that you can get it in its original format, or you can reproject it on the fly. You can choose which bands you want to see. So even just this getting an image, there's some nice functionality that Earth Engine provides. Then you can apply an algorithm to an image. So let's look back at this thing for a second. Now let's say you're getting data that looks like this, and you want something that looks more like this. How would you do it? Well, one thing you can do is, so Landsat goes over the same spot every 16 days or so. So at a given point, you have lots of images just over time. So one thing you can do is you can look, if you want to fill in these missing spots, you can look to earlier images and find where that information is not missing and fill it in. And with the same thing with the clouds, you can find images that don't have clouds and fill it in, right? So that's one approach to cleaning up the imagery so that you can use it later. So one way to do that is to look at an image and to like find the good pixels. Like find me the pixels that are not cloudy, find me the pixels that aren't missing information. And you would use an algorithm for that. So another thing you can do with Earth Engine is take an image and apply an algorithm to that image. We have collections. Collections are like the entire Landsat 7 archive or the entire Landsat 5, which is another satellite archive. And you can filter the collection. So you can say, give me Landsat 7 over the Survey territory during this time span. So that's filtering the collection. And once you've done that, you can say, now apply an algorithm to every single image in that collection. So for every image, find me where there are no clouds and find me where there are no bands. And now you have a stack of images, each of which you know where the good data are, and now you can kind of squash them together so that you get one clean image, which isn't missing any data, unless it's missing data at all the points, and then you're stuck. But hopefully there's enough data that you don't have that problem. So that's what this reduction is. It takes a bunch of images that you've analyzed and collapses them into one. And then you can also do sort of aggregate statistics. So over an image, you can find the highest value, the lowest value, the average value, all that kind of stuff. So those are the types of things that application can do, and we'll do some of this after lunch, so you'll see how it works. One interesting thing about running the algorithms is all the algorithms are parallelized to run over a lot of computers in the Google cluster, which means that we can do lots of analyses pretty quickly. So the way that works is you take an image, and you want to run an algorithm over this image. We take that image and we divide it up into little bits. And we kind of send each bit to a different computer. And each computer does its work on that little part. And you put the image together. And then you're done. So when you're doing analysis, that's the process for any image. And any analysis that happens using our programming interface, all this parallelization is kind of invisible. You don't ever have to know about it. Our system takes care of it. You don't have to worry about provisioning computers and figuring out which ones are running what or any of that kind of stuff. It all kind of happens without you knowing. So with this kind of technique and the API, the analysis I showed you, we've been working with our science partners to develop products. This is one that is I like a lot. This is the Landsat scale, fairly high resolution forest, non-forest map of Mexico. It's 52,000 Landsat scenes, 15,000 hours of CPU time cranking through to come up with this map. But, and that's about, if you ran it on one CPU, it would take a couple of years, like 3 years, if nothing went wrong. Like you didn't have a power outage or the internet didn't go down or something like that. But since we were able to deploy it on lots of machines, it ran less than a day. And it's kind of nice, this image is kind of nice. Here's Cancun up there. This is the kind of data that we were working with. So we worked with a guy named Matt Hansen on this. He's the one who provided the algorithms. And without our science partners, none of this stuff really works. We rely on our science partners and the NGOs that we're working with to supply us the actual know-how to do the remote sensing. We're just doing the kind of the plumbing. So we take data like this and get something nice out here. So this is, where it's lighter is where there's no forest, where it's darker there's forest. Let's see. Okay. So there are a couple of other things I didn't mention. I'm almost done with this, which are very nice for conservation work. One is we've designed the platform so that any analysis that's done can be easily redone. So whenever you have a map, like the Mexican forest map, you can see what all the inputs were, and you can see what the algorithms were. The way that works is any algorithm that we have in our system, we version it. And if the algorithm is changed, we keep a version. And when you look at a product, it stores which version of the algorithm was used to generate that product. And the same is true for data. If you have data, we version the data, and we keep track of all the versions of the data. And for any product, you can look back and see what were the data that went into this, and what are the algorithms. So that's nice if you come up with a result, and somebody calls you on it, and says, that's absolutely not true. You can go and say, well, you can rerun it yourself and see what the assumptions were, because all that information is stored with the product. Another nice thing in the platform is we have access controls. So your data can be kept private, your algorithms can be kept private, and you can choose what to share with whom. And the other thing that's nice about it, if I talk about this a little bit, is that it's extensible. So you can write your own algorithms, or you can use the ones that we already have. And you can also, rather than using websites that we've built, which is what we're going to look at lunch, you can, like the Amazon folks, build your own websites. So to summarize, this is Earth Engine in a nutshell. Lots of satellite imagery that you can access easily. Ways of doing analyses on the imagery. And the ability to parallelize those analyses over lots of computers in the Google cluster without really paying attention to what you're doing. I want to thank some of the science partners that we've worked with, because they're the ones who really provide us, make our system useful. And we're hoping that some of you folks will work with us to add more to the system. These are some of the folks we're working with. Some of them are actually here. Carlos is the main person that we've worked with Amazon, and Leon is here today, so I'll talk a little bit about our work. And so we have other folks too, and we hope that you will join us. And thanks. So a couple of minutes for questions. So the question is, do you have to use the same algorithms in different areas, given that you need a different algorithm for different areas, right? Yeah, that's a good question. It's absolutely true. So a lot of these deforestation, most of the deforestation algorithms are very highly tuned to different areas. And the system was built to let you program your own. So for if you have an algorithm that works better in one area than the ones that we have that work well, let's say the Amazon, you can use the system to code up those algorithms and run them.
Can you choose your make the algorithm depending on the different status? If I make the algorithm, can I upload the algorithm?
Can you upload the algorithm? Yeah. Yeah, so you can share the algorithm if you want or not.